The graphing calculator program should be able to graph 5 different functions. The more of these you get, the more points you get. So here's an example. I have realized that the window is wider than it is tall, so I like to go like from -4 to 4 going across and -3 to 3 going up and down. It makes the scale pretty uniform, something on those proportions, 4 to 3. And I'll graph a line. So A, I'm going to graph a line. Boop. What should my slope be? Let's do a slope of 2 and a y-intercept of 1. How about that? Boop. Oh, it's crawling along down here at the bottom. It's out of range. And then boom, it actually fits within the window for a while. Graphs my line. Gosh, this is awfully slow. Sure wish there was a turbo mode. There is, but I'd have to go inside to see it. And it's off the screen again because it's trying to graph way up here above the graph. So I'm going to go see inside, but I don't want you to see too much of what's inside there. So zoom out, scroll up. Yeah, you can freeze the screen, I suppose. Let's turn on turbo mode. Boop. Try this again. -4 to 4, -3 to 3. Let's do a parabola. Parabolas are ax squared plus bx plus c. Lets me choose my a and b and c. So let's make a like 0.3. That'll make it nice and wide. Let's make b 1 and c -1. How about that? Boom. Parabola. Try again. Turbo mode is great. -4 to 4, -3 to 3. C, let's do a sine curve. Now, oops, C. Sine curves really like radians, so I have to decide, are these degrees? 1 degree, 2 degrees, 3 degrees? Gosh, I'd have to have my scale set from like -360 to +360 if I do it in degrees. So I switched mine to radians, which means whatever I calculated here, I have to convert to degrees so that the sine function in Scratch does the right thing. But you can figure that out, how to go from radians to degrees. So let's have an amplitude of 2. And B is how fast it wiggles. Let's make it wiggle really fast. 3. And C is the phase shift. Now let's have no phase shift. Boom. There's a sine curve. Try again. -4 to 4, -3 to 3. Let's do an ellipse. D. Ellipses are x squared over a squared plus y squared over b squared all equal 1. That's if the ellipse is centered at the origin, which I'm going to just assume is true for mine. All right. This isn't a function, right? So let me turn turbo mode off so you can see how I made this work. A is how wide it is from the center out. So let's have it go 3 wide. And B is how tall it is up and down from the center. So let's go 2 up and down. So that should, go all the way around and hit those hash marks as it goes. Let's see what it does. Since it's not a function, I broke it up into 2 parts. I'll do the top half of the function, or the relation in this case. And then when that's done, I'll do the bottom half. And since it's an ellipse, it's only going to be valid from -a to +a, -b to +b on y. So I limit my x ranges for that when I'm drawing it. All right, so there's my ellipse drawing tool. And let's do one more. Let's do -4 to 4, -3 to 3. Let's do a polar function. Polar functions are of this form. I went ahead and left this all in degrees this time. And I have theta start at 0 degrees and then 90. I just have it go all the way around different angles, tiny steps in angle, till it makes it around to 360. So let's make a. Should we draw a circle? Should we draw petals on a flower? What should we draw? Oh, shucks. Let's make A1, B1, and C will determine how many loop-de-loops are inside there. So let's do 3. And is turbo mode off? It is. Here it goes. Oh, this looks like it's going to take a long time. So it's drawing a petal out there. I could have added a phase shift and then made the petals not centered on the axis, but that's okay. It's thinking, it's thinking. I better turn on turbo mode so I can see what it's doing here. Turbo, ka-chow. Oh, there they are. 3 petal thing. Let's do another polar. -4 to 4, -3 to 3. Polar F. Let's do 0 for A, 2 for B, and 1 for C. This should be a circle. Oop, there it is. Circle of radius 1. Okay. It might actually be faster to have it do the ellipses in polar rather than have it do the ellipses in rectangular, but that's up to you. So I just wanted to demonstrate what I'm hoping you can get your program to do, just to let you know that it works on different uh, max and min y values. Let's go -2x out to 5x and -1y up to 4y. It's kind of covering up my axes there a little bit. And let's do a line, a slope of 1.5 and a y-intercept of 1. Go. There you are. Alrighty. That's what I'm hoping you can try to create. You'll learn a lot of math along the way if you've forgotten some. And video 1 was showing you how to get the axes drawn and how to convert the logical x and y values that you're thinking of, like the point 2, 1. How do I get it there when there's 400 and some pixels this way and 300 some pixels that way? How do you do it? So this is what I'm hoping you'll do as the end goal. And if you would like help on doing a particular function, one of those 5, I'll do this real quick so I can show you them again. A line, a parabola, sine, ellipse, or polar. I have to tell you, once I got line done, parabola was pretty easy, and so was sine. I just had to copy the code over and change a few things. On sine, I had to do the little radian to degree thing. Ellipse was interesting because I broke it up into 2 halves, and in polar, you just have to remember that in polar form, if you have r and theta, you can convert those to x and y using some trigonometry and some right triangles. So maybe you'll remember how to do that, maybe you won't. But if you can get line, parabola, and sine, you're sure to get a B if you can have it do kind of what I've shown you it does. Do ellipse, you'll get into the A minus range. Do polar, you'll get the A plus range. That's my task for you. I hope this demonstration makes sense. And ask questions and don't delay.